In this session, we can see about the Feistel Cipher. Okay, Feistel Cipher. Feistel Cipher is nothing but it's a structure used in design of block chipper. Already we know about the block chippers. Okay, so this Feistel Cipher is a structure used to design that block chipper. Okay, so it was developed by Host Feistel and used in data encryption standard and other encryption algorithm. So it can provide both encryption and decryption using same algorithm. So this is the working principle. So a Feistel Cipher divides the input data into two halves. Okay, so first the input data will be divided into two halves and process them through multiple rounds using a round function and XOR operation. Okay, so the Feistel Cipher working on this process. The first one divides the input data into two halves and then applying the round function and then XOR operation. Okay, so here are the encryption process. So this encryption process divide the plain text into two equal halves. Okay, so for example, if you are having 8 bits, so the first 4 bit will be considered as the left half and then the next bit will be considered as the right half. Okay, so then we are applying the round function. The second function is the round function. So round function will be considered as the right half and the first key. Okay, so we are applying the XOR for this value and then swapping the halves. Okay, so here applying the function, then applying the XOR function and swapping the halves, and then we are repeating the multiple rounds. Okay, example, in the DES algorithm 16 rounds will be there. Okay, the final ciphertext is obtained as the after the last round. Okay, so the decryption process also the same process is used, but the key applied in reverse order. Here K1 to K16 and the decryption algorithm K16 to K1. So after reversing all rounds, the original plain text is recovered. Okay, so there are three functions. The first function is divided into two halves, equal halves. Then we are applying the round function using this one, and then we are applying the XOR operations. Okay, so let's check with one example. Let's take an 8-bit plain text. Okay, plain text that is 10101100. Okay, so we are having an 8-bit plain text that is 10101100. Okay, so the first step, we are dividing these 8 bits into two equal halves. Okay, so this plain text, that is, this will be called as L0 and this will be called as R0. Okay, and let us assume that two keys are there. So two keys, that is, first key K1 equal to 1101 and K2 equal to 0110. This is called as key 1, and this is called as key 2. Okay, so the first step over, that means we divided the 8 bits into two equal halves. This is the plain text given and we divided into two equal halves. Okay, so now the next step, we are going to apply the rounds. Okay, so the first round, so we are going to apply the first round. So the first round, this is the second step, that is, we are going to apply the first round, that is function of R0 comma K1, that is, like this we are choosing. We are R0 comma K1. Okay, so R0 comma K1. What we are getting, what is R0? That is 1100. And what is K1? K1 is 1101. Okay, so we are going to apply R0. So 0 1 is 1, 0 0 is 0, 1 1 is 0 0, and 1 1 is 0. Okay, so we have applied the first round function. Okay, now we are going to XOR with L0. Okay, so the first half, that is XOR with L0. That means this is the output function we got, and we are going to apply L0 here. L0, what is L0? That is 1. What is L0 here? This is L0. 1 0, 1 0, 1 0. So we are applying the XOR here. So 1 0 is 1, 0 1 is 1, 0 0 is 0, and 1 0 is 1. Okay, so now this is called as the new function, that is R1. So new function, that is R1. Okay, so basically 3 steps are there, dividing into 2 halves, applying the round functions. So this is the round function we got. Now we need to swap the values, swap the halves. That means this R0 will be comes shifted here, that is L0, and this R1 will be the right function. Okay, so swapping the halves. Okay, so this is the general structure that we will see finally. Okay, so swapping the halves. So swapping the half means, so now what is the R, first this R0 will come first. So okay, so what is R0 now? That is 1 1 0 0. This will comes here, that is this will be the new L1. Okay, so swapping, we are swapping. So 1 1 0 0 will be the L1 swapping. So 1 1 0 0 is the L1, and the R1 we got is 1 0 1 0 1 1. So this is the R1 we received, 1 0 1 1. So this is the R1. Okay, right. So now this is the new bits we received, new 8 bits. Okay, now again we are going to apply the second round. Okay, we are going to apply the second round of function. Okay, so first function we perform for R0 comma K1. Now we are going to apply for R1 and K2. Okay, so what is R1? R1 is this one, that is 1 0 1 1, that is R1. And what is K2? That is the key, second key. Second key is 0 1 1 0. Second key 0 1 1 0. So we are applying the XOR 1 0, that is 1, 1 1, that is 0, 1 and 1. Now next we need to apply XOR with L1. What is L1? L1 is 1 1 0 0. Okay, so again we are applying the XOR 1 0, that is 1 0 0 0 0 0. So now this is the new round we got. Okay, so this is the new round we got. Okay, now again the final step is, again we need to swapping the values. Swapping means now this R2, this is the new R2. Already we are having one R1. Okay, this R1 will be the left tab. Okay, so the final digit, that R1 will be 1 0 1 1, and R2 0 0 0 1. So this is the final cipher we got. So this is the final 8 digit we received. Okay, so block wise the picture is represented like this. So this is the representation. So here the plain text, okay, the plain text will be divided into 2 equal halves, left and right. Now the functions will be applied. Okay, After once the functions is applied, the exhaust will be performed and the swapping will be performed. The new R1 will be the left value and the key, second key will be used, and so on. The final values we got is the final cipher text. This is all about the Feistel Cipher. Okay, thank you.